students, I am Nilanjana Sunyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now from today onwards, we will be starting with the binomial expansion, where the power of the binomial expression, that is n, will be a rational number. So far we have seen n was, that is the power of the binomial expression, n was always a positive integer. But from now onwards it will be a rational number. You may be saying that aren't positive integers rational numbers? Of course they are rational numbers. But when I am saying that n will be a rational number, I am meaning that the power of the binomial expression can be a negative integer, it can be a fraction. That means the power will be a rational number. It can be a positive integer as well, no harm, but it can be a negative integer as well. Okay? And since positive integers are also rational numbers, therefore you will be seeing that the method that we were applying before is very similar to the method that we will be applying now. There will be few restrictions over here, but they will be just very nominal and don't have to worry about them. Let's start with today's session. Let's see how things go. Okay? So the first thing that we will be learning is the binomial coefficient, that is NCR, where n belongs to the set of rational numbers, that is Q, and R belongs to the set of whole numbers, that is W. Our starting value is equal to 0 and all the remaining values are natural numbers or positive integers. That is the whole number set actually. Okay? So when we see this expression, this NCR format, this notation rather, what comes to our mind? How does it get expanded? We know NCR when n belongs to the set of positive integers or natural numbers. NCR is equal to n factorial over r factorial times n minus r whole factorial. And if r is equal to 0, then n factorial will be in the numerator and n minus 0, which is n factorial, will be in the denominator, which can cancel each other. But if r is not equal to 0, then between n and n minus r, n will be the larger number, and we always express the larger numbers factorial in terms of the smaller numbers factorial. Therefore, we will be expressing n factorial in terms of n minus r factorial. Okay? So, the denominator will remain the same, r factorial times n minus r whole factorial. But the numerator becomes this, n times n minus 1. Now, if it is say 7 factorial, what is 7 factorial? Since it is 7 factorial, the starting number will be 7. 7 times 6 times 5 times, it just goes on, continues till we reach 1. This is the expansion of 7 factorial. So, in place of 7, if I write n, I'll be starting with n, just like I'm starting with 7 over here. And what will be the remaining numbers? 6 is 7 minus 1. So, it will be n minus 1. 5 will be n minus 2. Okay, 7 minus 2, so n minus 2. That way, it will be just going on decreasing in steps of 1. So, I have written exactly the same. It starts with n, then n minus 1, then n minus 2, next n minus 3. It continues and it will be continuing till 1. But we do not have to go till 1 because there is this n minus r whole factorial in the denominator. So, we can continue till n minus r factorial. Okay. So this actually this is the cancellation. It has the strikeout thing has come over here. So, and what is the immediately previous factor previous to n minus r? It is obviously n minus r plus 1, okay, because n minus r plus 1 and then minus 1 will be giving you n minus r as the succeeding factor, okay. So, it is n times n minus 1 times n minus 2 continues, and what is the last factor? It is n minus r plus 1. And now coming to the next step, in the denominator we have only this r factorial, and in the numerator it is starting with n minus 1, n minus 2, it is continuing, and this n minus r plus 1 can be written as n minus, and within parenthesis we have r minus 1, okay. So we see that when r factorial is in the denominator, where are we stopping? We are stopping where n is, r minus 1, that is 1 less than the denominator's number, is getting subtracted from n. This is our last factor, okay. That is why we have in the binomial expansion, remember when we had taken the sigma notation, we had taken r equal to 0 to n, because if we take r equal to n plus 1, if we take r equal to n plus 1, what happens to this part? N minus r minus 1. If r is equal to n plus 1, what happens to this part? N minus, in place of r I am writing n plus 1, minus 1. And this is n minus n, which will be equal to 0. And if we get a 0 as one of the factors, all are getting multiplied. So the entire numerator will be equal to 0. That is why we stop when r is equal to n. This is the restriction that I was talking about. When n belongs to the set of positive integers, we stop when r is equal to n. Okay? Because if we take r as n plus 1, the whole thing will be getting evaluated to 0, because this last factor will be having a value of 0. Okay, that is why we stop at r equal to n. But when n belongs to the set of rational numbers, it will not be that way. It can continue till infinity. You do not have to stop when r equal to n. Okay, but there is some certain other condition that has to get satisfied. We will be knowing about them in our future sessions. Okay, but for our today's session, we are interested in getting the binomial coefficient of the binomial expansion when n belongs to the set of rational numbers. And as always, NC0 equal to 1. Okay, and this was the case for n belonging to the set of positive integers or natural numbers. Now we are coming to this part. This is true even when n belongs to the set of rational numbers. Means NCR is equal to this, no matter whether n is a positive integer or n is a rational number, which can be a negative integer or a fraction as well. Okay, this NCR expression is exactly the same, and r is equal to 0 or any positive integer. In the numerator, we get the last factor, that is this factor, when r minus 1 gets subtracted from n. whatever is the r value when r minus 1 gets subtracted from n, that will be our last factor in the numerator. And in the denominator, you are having r factorial. Okay. In the numerator, it starts with n, goes on decreasing in steps of 1. Last factor will be n minus r minus 1, and in the denominator, it will be r factorial. Okay. So now let us do few questions on how to expand NCR when n belongs to the set of rational numbers. Okay. So this is a single question containing 4 subparts. Evaluate the binomial coefficients. Each of them is equivalent to NCR. And we are seeing for each of them the upper number is n. So n belongs to the set of rational numbers. N is either a fraction or this is a rational number, that is, it is having, I cannot term this as a fraction because you don't have negative fractions. This is a fraction, this is a rational number, this is a negative integer, this is again a fraction. So it belongs to, n belongs to the set of rational numbers. And we have to evaluate these NCRs. So let's start with our answer. First one, subpart A, half C1. That means n is equal to half, r is equal to 1. So what will be the expansion? It will be half C1 is equal to, the denominator will be r factorial, that is 1 factorial. Okay. And the numerator, it will be starting with half, that is n. Where will it be ending? It will be ending where r minus 1, that is r is equal to 1. So r minus 1 is 1 minus 1. 0 gets subtracted from the value of n. Let me write the last factor expression. It is actually NCR. Let me write it over here because it is new to you. So it is n times n minus 1. It continues up to n minus r minus 1 over r factorial. This is the expansion. When r is equal to 1, 1 minus 1 will be equal to 0. When 0 is getting subtracted from n, that will be the last factor. When we are writing n, what is getting subtracted from n? It is 0. So, the only factor that will be present in this case is half. You cannot come to n minus 1. Okay? Because only 0 can be subtracted from n. So we are having half in the numerator and 1 factorial, which is 1, in the denominator. So what is this equal to? Let me just, So this is equal to half. Because half over 1 is equal to half. So this is our answer for the subpart A. What about subpart B? It is minus 1 over 3 and 2. Minus 1 over 3, C2. So for this case, n is equal to negative 1 over 3 and r is equal to 2. So what is negative 1 over 3 C2? It is equal to, in the denominator it will be 2 factorial. and in the numerator it will be starting with the value of n, that is negative 1 over 3. And what will be the last term? It will be r is 2. So 2 minus 1. That is when 1 will be getting subtracted from n. 1 gets subtracted from n in the very second factor. So we will be having only two factors, n and n minus 1 in the numerator. Okay. So the second factor will be negative 1 over 3. Negative 1 over 3 minus 1. Okay. And this is equal to negative 1 over 3 times negative 1 over 3, and this can be considered as negative 1 can be considered as negative 3 over 3. So this is negative 1 over 3, negative 3 over 3 is equal to negative 4 over 3. Okay. And 2 factorial is 2. So this is equal to, and negative times negative is positive. So 1 times 4 is 4 over 9. So 4 over 9 times 1 over 2, which is equal to 2 over 9. Okay. Coming to subpart C. Negative 1, this time n is a negative integer. R is equal to 3. So n is equal to negative 1, R is equal to 3. What is negative 1 C3 equal to? The denominator will be equal to 3 factorial. And the numerator, the first factor of the numerator is negative 1, which is n. And what will be the last factor? R is equal to 3. So 3 minus 1, that is 2. Last factor will be when 2 gets subtracted from n. That will be the third factor, n times n minus 1 times n minus 2. So you will be having 3 factors in the numerator. So negative 1 is the first factor, then negative 1 is the second factor, and negative 1, negative 2, negative 1 minus 2. This is the third factor. And minus 1 is minus 2. And this is minus 1 is minus 3. Minus 2 minus 3 is plus 6. And minus 1, which is equal to minus 6. And 3 factorial is what? 3 factorial is 3 times 2 times 1, which is equal to plus 6. So this is equal to negative 6 over 6, which is equal to negative 1. Clear? So negative 1 C3 is equal to negative 1. And the subpart D is half C3. Half C3, where n is equal to half, R is equal to 3. So half C3 is, the denominator will be 3 factorial. It will be starting, the numerator will be starting with half and ending where? 3 minus 1, that is 2. When 2 will be getting subtracted from n, that will be the third factor. So you will be having 3 factors in the numerator. Okay. So first factor is half, second factor is half minus 1, third factor is half minus 2. half minus 1 is minus half, that is negative half. Negative half times positive half is negative 1 over 4. So it is negative 1 over 4, and what is this? Minus 2 can be thought of as minus 4 over 2, and minus 4 plus 1 is minus 3. So this is minus 3 over 2. Clear? And 3 factorial is 6. So, negative 1/4 times negative 3 over 2, which is equal to 3 over 8. 3 over 8 times 1 over 6, which is equal to 1 over 16. Okay, so you see, when r was equal to 1, for subpart A, r was equal to 1, you had only one factor in the numerator. When r is equal to 2, you are having two factors in the numerator. When r is equal to 3, you are having three factors in the numerator. So whatever may be the value of r, you will be having that number of factors in the numerator. Clear? So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. So bye for now.